Hello, welcome back. Today I show you a solution to another problem from Strive's SDE Sheet. It's called search in a 2D matrix. And what the problem states, as an input we have the 2D matrix and the target number we need to find in that matrix. Matrix, each row of the matrix is ordered and also uh, in each row the last element is smaller than the first element of next row. So when I hear ordered, the first thought I have is binary search, and basically yeah, that's the answer for to this problem. And we'll be performing two binary searches. First binary search will be performed on first elements of each row, and we'll be looking for a row where first element is smaller than the number we need to find. So like here, it will be looking in this row. But the second constraint is that the first element of next row, the row next to it, the next row needs to be bigger than the number we are looking for. And when we find that the row, we're just performing then the classical binary search, nothing to add, nothing. It's a normal binary search. Maybe I'll record another video specifically on the binary search and link to that if someone interested to check out it. All right, and then let's jump to that first binary search which will be searching through that first column. So we need to find the number of a row which, as I said before, uh, which first number of that row is smaller than the target we're looking for, and the first number of the next row is bigger. So we're checking the first condition. If the target is bigger than the first number in a row, that's well entering solution, and the entering condition, if it's met, we need to check some the second condition. We'll be checking it here. So because for if the first number of the second row of the row after it is bigger than the number we're looking for, and for example here will be first row, the row will be looking in, because when we're looking for 3, the one is smaller, then it's bigger. But for example, if we'll be looking for 16 and we'll be checking this row, we see that the first element of the row in which we'll be potentially looking for is smaller, but the second condition isn't met. So the first element of the row, which is after the row we're potentially checking, is smaller. So the condition is met. We'll skip to else, in which we'll be increasing the minimal value. So we'll be well decreasing the window in which we'll be looking for. We'll be moving it to the minimal value closer to the middle of it. But there's also another condition here. So if we check all the rows and we don't find the row that meet the uh, two conditions with those two values, so one smaller, one bigger, we'll be just checking the last row, and here's the condition that's responsible for that check. Okay, and what is happening if the value uh, is smaller than the first value? So, for example, like here or here, if we're looking for free and we check with 10, then we're just making the max value. So we're decreasing that window when we're looking for from the front to the middle, and then we're just repeating the loop and looking once again. And here, if the value, if the both conditions are met, then this is the only branch when we're performing that normal binary search on a row. Uh, yeah, so basically that's it. That's the solution. Two-step solution. Uh, yeah, so that's it. Submission is working. There was a couple of tries to get that, but I guess the time it's quite satisfying. Time runtime is quite satisfying. Yeah, so basically that's it. Code and link to the problem in driver search will be in the description. So that's all for now, and see you next time. Bye.